So this is the Pre-Calculus Math 1140 worksheet for rational functions and graphing, and we're looking at question number 5. It's asking us to identify all asymptotes and sketch the graph. We're given f of x is equal to 2x minus 3 divided by 5x plus 10. To determine our asymptotes, we're going to go ahead and look at the degrees of the numerator and the denominator. So as we can see, the degree of the numerator is 1 and the degree of the denominator is 1. Since they are equal to each other, we have to take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. So our asymptote is going to be a horizontal asymptote at 2/5. So I'm just going to go ahead and write this in decimal forms. It's a little easier to graph. This is approximately 0.40. Now that we have our horizontal asymptote, we can go ahead and solve for our vertical asymptote. And I'm going to do this by taking the denominator and setting it equal to 0 and solving for x. So when we do that, we need to isolate our x term, and then isolate our x again. So you should get that you have a vertical asymptote at -2. Now we're going to go ahead and graph this. So the horizontal asymptote is going to be at y is equal to 0.4, which is about right here, I would say. Let's go ahead and draw that horizontal asymptote out with a dashed line. Now let's go ahead and draw a vertical asymptote at x is equal to -2, so that's right here. And again, just draw that dashed line out. And just to be a little bit more accurate, I'm going to make a quick little xy table of 4 values just so I know kind of where my graph will be, even though we already know that the lines are going to hug our asymptotes. So when you do this, you're basically just going to plug in each x value into your original function until you solve for your y value, just so I know where the graph lies. So when you end up plugging in all those values just to get a better graph, this is what you end up with on the left. So I'm going to go ahead and plot this. So you're going to have -5, 0.086, that's almost 1. You'll have -3, 1.8, so it's about right there. And then you won't get a value when you go in and plug in -2 just because that is your asymptote and you won't have a point there. It'll pop up error. So we know that it hugs it and cuts in but never quite touches it. So that's going to be there. And then for the other part, we're going to have -1, -1, and then 1, -0.06. So again, it's never going to hit the asymptote just because it can't, and it's going to cut in close. So that's going to be the sketch graph for number 5. So looking at question 6, using the same instructions, we're going to go ahead and graph this and find all the asymptotes. So looking at the degree of our numerator, if we have a degree of 0, and for the denominator, we have a degree of 2. So we see the degree of the denominator is greater than the degree of the numerator. This means we have a horizontal asymptote at the x-axis, which is y is equal to 0. So let's go ahead and graph that piece. So now that our horizontal asymptote is graphed, let's go ahead and find our vertical asymptotes by setting the denominator equal to 0 and solving for x. So to solve for x, we're going to go ahead and factor out a common term, which we can see is the x value. We factor that, you're going to get x minus 3 times x is equal to 0. Now you take each individual argument and set that equal to 0. So we'll have x is equal to 0, x minus 3 is equal to 0, solve for x, which will get you x is equal to 3. So we know that our vertical asymptotes are going to be at x equals 0 and x is equal to 3. So let's go ahead and graph those. Now to sketch this, I'm just going to do a few different x and y values so I know what my graph looks like. So I went ahead and picked -4, -3, -2, and -1 for the left side of my vertical asymptote that is at 0. I picked 1, 1.5, and 2 for the middle portion of my graph, and then I picked 4, 5, and 6, so it's at the right hand side of my other vertical asymptote. So when I go ahead and plug each of these values back into my function, we're going to get these y values. So once you have your y values, let's go ahead and graph this. So -4 and -0.14. And then -3 and -0.22. Then -2 and -0.4. And then -1, -1. So let's go and draw the line for that one. As you can see, it kind of hugs this asymptote and then it curves down, and then it's going to hug in towards our vertical asymptote for that part. So let's move on to our second xy table. Let's go to 1, 2. Then we'll have 1.5 and 1.78, which is about like right here. And then we'll have 2, 2. So that's a very compressed parabola. It's going to hug up towards that. And then our last value is at 4, negative 1, 5, negative 0.4, and 6, negative 0.22. So again, it has that slight curve to it and a downward angle. So that's going to be the sketch graph for number 6. So now let's go ahead and follow the same directions in graph number 7. So we're getting f of x is equal to x cubed minus 16x divided by negative 4x squared plus 4x plus 24. So as we can see, the degree of the numerator is 3 and the degree of the denominator is 2. So we know that the numerator is greater than the denominator in terms of the exponent. This means that we're going to have no horizontal asymptote. So let's go ahead and find our vertical asymptotes now. Again, to do that, we're going to set our denominator equal to 0 and solve for x. So this is a quadratic, so you're going to use factoring, but to go ahead and do that first, I'm going to divide every term by negative 4 to get rid of the leading coefficient in front of our x squared. Now we can go ahead and factor that now that's simplified. I use the AC method that I was taught, and to do this, we're going to go back to basically the standard written version of a quadratic formula, which is ax squared plus bx plus c. And we know that our a value is this is our b, and this is our c. So our a is 1, our b is negative 1, and our c is negative 6. So with the AC value, you go ahead and you take your AC values and you multiply them by each other. That will get us negative 6. And the right hand side, you take your b value. So you want to find two numbers that will multiply by each other to get you to negative 6, but if you add or subtract them by each other, it'll get you to negative 1. So automatically, off the top of my head, I am thinking of negative 3 and positive 2. When you multiply them by each other, you'll get to negative 6, and negative 3 plus positive 2 is negative 1. So when we write that, you're going to have x minus 3 and x plus 2 is equal to 0. Now you take each argument and you set equal to 0 by itself. And you solve for x. So you'll have x is equal to positive 3 and x is equal to negative 2 as your vertical asymptotes. So let's go ahead and graph those vertical asymptotes. So now that those are graphed, I'm going to go ahead and get, again, some xy tables put up so I can figure out what my graph looks like. So I just chose some x values that were both to the left of my vertical asymptotes, in the middle, in between the two, and then to the right of my other one. So let's go ahead and plug these x values into our original function to get to our corresponding y values. These are the y values I get that I have written out in decimal format because it's just easier to graph that way. So once we have those, we can go ahead and graph our final points. So let's start with negative 6 and 0.83, and then negative 4 is 0, and then negative 3 is 0.87. So this is going to come out to be our next xy table. We'll have negative 1 and 0.9375, 0, 0, 1 and negative 0.625, and 2, negative 1.5. So again, when we draw that, it's going to hug that asymptote, curve down, and curve against that one. And our last set of points. We will have 4, 0, 5, negative 0.80, and 6, negative 1.25. When that one's drawn out, it's going to look like this. And that will be your final sketched graph for number 7.